Hi, once again, my name is Spencer Dunleavy. I'm a fourth-year medical student here at Columbia. In this video, you're going to learn a little bit about how to manipulate textual data. In R, this data type is called character, but in most other languages, as I've said before, it's referred to as string. So I'll use them interchangeably throughout this video. A string or character is a sequence of text enclosed in quotations or apostrophes, either the double quotations or the single quotations. As an example, as you've seen before, I can define a string and check the type of it to see that it is in fact called character in R. One of the simplest things we can do to strings is to combine them. You can do this using the paste function. You can combine any number of strings you want using this command. Here, I've defined two strings, my string 1 as this sentence, and my string 2 as this sentence. Using the paste command, where I just do paste, parentheses, and then the list of strings I want, I can create a new combined string. When you see this together, you see that it creates this one run-on sentence. Now, you may notice that this combined or concatenated string puts a space between the two initial strings that I put in the paste function. I can specify the placement of any other divider I want by using the sep equals parameter in the paste function. So here you can see the same thing where I do paste of my string. Now I use the sep parameter and I define it as a dash. So this is then stored in my new variable, which I've named appropriately dash string. And when I run it, you can see that there is now a dash between my two strings. Now, if I want to make this grammatically correct, I could specify my separator as a period with a space. So now when I run that command, I can see that things are actually separated out. Paste is even more flexible. You can put in other data types that may convert to character types to create more complex variables. So here I'm going to construct a much more complicated sentence. Here I'm going to define place as a store. I'm going to store the quantity as a number, which is a numeric variable. I'm going to define food as a string of eggs. And then I'm going to define the price as the quantity, which is a number, times the price per egg. If I want to define my overall sentence, I can use the paste command and piece together all of these different variables. So I use I went to the, which is a new string. I defined a place, and bought, and I define a quantity, food. Then I have a new string for a total cost of, I specify my price, and then I can say dollars. Here, I want to separate everything by a space, so I've defined that. When I run this whole sequence of commands, you can see that I am now able to create a dynamic sentence within this string. If you want to find the number of individual characters in a string, you can use the nchar or length functions. Here, I use nchar to test how many individual letters or characters are within this string. If I run this, you can see that there are 65 characters within that. You can also take pieces out of strings, creating a substring that you can use for other purposes. The substring function, sub-str parentheses, will be the most basic way to do this. So now we're just going to quickly look at the documentation of substring. Here, it says, give me your string as x, define the starting character you want to work in. So this could be starting at 1, and then going to some other stop character, for instance, 5. So if I specified 1 and 5 here, it would go from the first position to the 5th position within my string. So let's now try this out. If I define my string as acute pancreatitis, I can then do a substring of the first 5 letters as I just described by taking my string and saying start at 1, start at 5. When I run this, you can see that the first 5 letters are just the word acute. I can also do this based on the last 5 letters. So I use the substring command, I specify my string. My start position is a little bit more complicated. It takes the length of the string and goes backwards 4 to say, okay, I want you to go to the final position and move backwards a little bit. And then I want you to go all the way to the end. So the stop position is just the number of characters in my string. When I run this, you can see that the last 5 letters are Titus. Now I can also define things in the middle of the string. So if I wanted to get the 7th through 10th letters, I can just do that as well by specifying that in the substring command. Here you can see that the 7th through 10th letters in my string were pank. Sometimes you may want to split up a string into a bunch of other strings. This often happens if you want to break things into words separated by spaces or other characters. The string split function is a great way to do this. So let's take a look at the documentation for string split. Here you specify X, which is your vector of characters or the individual word that you're looking at. Split says whichever thing you're going to use to actually divide it up. And then there are lots of other commands that you may or may not want to use depending on how complicated your task is. Here, I'm going to split up this string based on spaces. So I define my string as acute pancreatitis due to gallstones, which is the most common cause of acute pancreatitis. And now I'm going to use the string split function where I take my string and I say, divide up this string based on spaces. So what it will do is it'll chop all of my spaces so that I end up with different pieces and different words in a vector. If I run this, you can see that I now have a list that has all the different words that were divided by these spaces. Here, I can do it with a different character. So I have this sentence, my string, you will do great, I believe in you. If I want to split this up based on the semicolon, I can just specify that as my split parameter in the function. If I run this, it'll now divide it into two pieces. You will do great, and I believe in you. Often, you'll get data that accidentally has a space before or after that you didn't notice when you imported it. This may be just due to clerical entry problems or copy and paste or anything else. This can cause problems in some tasks where you want to do substrings and the numbers are all shifted. So I define my string as, oops, I did it again, but I have this leading space here. So if I wanted to manually pull out oops, you would think, oh yeah, that's just the first four letters. Well, when I do my substring command and say start at the first character and go to the fourth character, it is going to include that space in its count. And so it's not going to pull out oops, it's going to pull out space oop. Now, rather than manually changing all of your counts, you can use the trim whitespace command, as I've described here, to get rid of spaces at the front and back of your string. So here, I'm going to use this command, trim whitespace. I'm going to take my string, which had this space at the front. It'll take that string, it'll cut out any spaces at the beginning or end, store it in no space string, and now you can see that I've redefined this variable so that there's no space at the front. Now, maybe you want to compare values and some are lowercase and some are uppercase. It's often useful to convert everything to one case using either the toLower command or the toUpper command. So here's a mixture of cases in one string. My string is now defined as data science, the health of New Yorkers. If I want to convert everything in this string to lowercase, I could use the toLower command and my string. So I define my string and I use the toLower command, and you can see all of that is lowercase. Similarly, I can use all uppercase if I want to. Here I use the toUpper command on my string and I run it, and you can see that now all of it is uppercase. Finding sequences of letters and numbers in a string is a really useful skill. This gets a lot more complicated very quickly, so we're going to start with something simple. So here I'm going to define my string as the quick brown fox jumps over the lazy dog, which uses every letter in the alphabet. I'm going to check, is there a Z in that sentence? We know that there is in fact a Z. It's in the word lazy. The grepl command just tells us if that is in fact there. The way to do this is you type grepl, you check for a pattern in your string. Here I'm looking for Z, and then I specify my string. So I say X equals my string. If I run this, it'll return true. This means that there is in fact a Z in my string. Now, if I want to replace the first occurrence of a sequence in a string, I can also use the sub command. So again, I'll define my sentence as the quick brown fox jumps over the lazy dog, but I'm going to replace something. I'm going to define a new string, and it's going to substitute wherever it sees brown fox, it's going to replace black cat. It is going into my string. All of that information will then be stored in a new variable, my new string. When I run this, the sentence will read slightly differently. Now it'll say, the quick black cat jumps over the lazy dog, because black cat has replaced wherever the first occurrence of brown fox was. As I said a little bit before this, doing manipulations and finding letters in strings, it gets complicated really fast. You can learn a lot more by looking at all the different functions related to regular expressions, which includes grepl. This is way beyond the scope of this class, but you may find it useful in the future. I'm just going to briefly show that there are lots of commands that you can use to manipulate strings. So now you try. First, import the county health rankings dataset and limit it to just counties using the code below, as you've seen in multiple videos. Now, you're going to create a variable in the dataset that tells you how long the name of the county is for each row. Hint, you're going to need the nchar command, and it may be useful for you to use a for loop. Then, using the summary command, can you see how long the longest county name is?